Failure of wave theory to explain photoelectric effect. What is the failure? The classical wave theory of radiation could not explain the main features of the photoelectric effect. Its picture of continuous absorption of energy from radiation could not explain. Number one, the independence of K maximum on intensity. The existence of threshold frequency with nu zero. And third is the instantaneous nature of the phenomenon. Einstein's theory of photoelectric effect. What is Einstein's theory of photoelectric effect? Einstein explained photoelectric effect with the help of Planck's quantum theory. When a radiation of frequency nu is incident on a metal surface, it is absorbed in the form of discrete packets of energy called quanta or photons. A part of energy h nu of a photon is used to remove the electrons from the metal surface, and the remaining energy is used in giving kinetic energy to the photoelectrons. Einstein's photoelectric equation is K maximum equal to half mv maximum square. It will be equal to EV0, and it will be h nu minus W0, and it will be h nu minus nu 0, where W0 is the work function of the metal and nu 0 is the threshold frequency. All the experimental observations can be explained on the basis of Einstein's photoelectric emission. Compton scattering. What is Compton scattering? It is the phenomenon of increase in the wavelength of X-ray photons, which occurs when these radiations are scattered on striking an electron. Then difference in the wavelength of scattered and incident photon is called Compton shift, which is denoted by delta lambda, and that will be equal to delta lambda equal to h upon m0c under bracket 1 minus cos theta, where theta is the angle of scattering of the X-ray photon and m0 is the rest mass of the electron. Photocell. What is photocell? It is an arrangement which converts light energy into electrical energy. It works on the principle of photoelectric effect. It is used in cinematography for the reproduction of sound. Photocells are used to operate various control systems and in light measuring devices. Now, dual nature of radiation. What is dual nature of radiation? Light has dual nature. Now I am going to tell you about dual nature of radiation. Light has dual nature. It manifests itself as a wave in diffraction, interference, polarization, while it shows particle nature in photoelectric effect, Compton scattering, etc. Dual nature of matter. What is dual nature of matter? As there is complete equivalence between matter and radiation, and the principle of symmetry is always obeyed. De Broglie suggested that moving particles like protons, neutrons, electrons should be associated with the waves known as the de Broglie waves, and their wavelength is called the de Broglie wavelength. The de Broglie wavelength of a particle of mass m with velocity v is given by lambda equal to h upon p or equal to h upon mv, where h is the Planck's constant. The de Broglie wavelength is independent of the charge and the nature of the material particles. It has significantly measurable values for subatomic particles like electrons, protons, due to their small masses. For microscopic objects of everyday life, the de Broglie wavelength is extremely small, quite obeyed measurement. Now, de Broglie wavelength of an electron. Beam associated through a potential difference V is given by lambda equal to h upon under root 2 MeV, and it will be equal to 1.227 upon under root V Nm. nanometer. I hope you have liked my video. If you like my video, please like and subscribe my channel. Thank you.